Hi everyone, this video serves to go through the 2023 VJC H2 Chem Promo Paper 1. Question 1. Manganese has 4 naturally occurring stable isotopes with mass numbers ranging from 52 to 55. Before we look at the options, let us recall or recap what is the definition of isotopes. So isotopes are different atoms of the same element that have the same number of protons and electrons but different number of neutrons. So we are going to use this definition to help us to select the correct option. So answer here is D. Option A is wrong because even though both manganese ions have different mass number, they will still have the same number of protons. Whereas for options B and C, so again we've already mentioned that all the isotopes of manganese have the same number of electrons. So even if they have different mass numbers, they will still form ions that have the same electronic configuration. Next, manganese in its valence electron shell has a 3d5 4s2 configuration. So when the manganese atom loses 3 electrons to become manganese 3+, the ion has a 3d4 valence shell configuration, which is not what is mentioned in B. So D is correct. Why? Because remember that the angle of deflection of a charged particle in electric fields is directly proportional to the ratio of its charge over mass. So both of these ions have the same charge, but Mn3 + 52 is lower in mass than Mn3 + 54, which means that in the electric field it will be deflected to a larger extent. Next, question 2. Answer here is B. So for option 1, this statement is false. Although increasing number of protons does increase the first IE, which is due to the nuclear charge, increasing number of electron shells actually decreases the ionization energy due to the shielding effect. So the attraction between the nucleus and the valence electrons becomes weaker. So this statement 1 is wrong. Statement 2 is also wrong because even for electrons within the same shell, they can have different energy levels. So for example, 2p, if you are removing a 2p electron, a 2p electron will be higher in energy than a 2s electron, so it requires less energy to remove than a 2s electron, which means that if you are removing a 2p electron followed by 2s electron, the increase in ionization energy will not be linear because the trend doesn't apply across 2p and 2s. Lastly, second IE of element is always higher than first IE. This is correct because after the first ionization, the element has become a positively charged cation. So for the second IE, you are trying to remove electrons from a positively charged cation. There will be some attraction between the cation and the electron. So additional energy is required to overcome this attraction, which makes your second IE higher than your first IE. Question 3. Which reaction results in increase in bond angle with respect to the underlying atom? So for this question, you just apply your VSEPR to find out the number of bond and lone pairs around the atom before and after the reaction, and the answer is C. So in the NH2- ion, it was V-shaped or bent 105 degrees. After the reaction, it became ammonia. With 3 bond pairs, 1 lone pairs, it's trigonoplanar with 107 degrees. Question 4. Answer is A. A is the only option where all the rows are correct. So for option B, ice is not giant molecular, it is also simple molecular. For option C and D, both of them are non-polar, so the types of intermolecular forces should be ID-ID rather than PD-PD. Okay, carbon dioxide is non-polar, even though the carbon-oxygen double bond is polar. Because of the shape, it causes the dipole moments in the bonds to cancel out, which results in the CO2 molecule being non-polar. Question 5. Which compound has the highest solubility in water? So the answer here is A. The solubility of the compound in water depends on the interaction that the molecules can form with water, with ion dipole interactions being the strongest and thus the most energetically favorable to form, followed by hydrogen bonding, followed by PD-PD interactions, followed by PD-ID interactions. So for option A, this is an ionic salt. It can form ion dipole interactions with water. For option B, this is alkane. It is non-polar. It can only form PD-ID interactions with water. Option C is an amine. The NH2 group has a lone pair. It can engage in hydrogen bonding with water. And option D is polar, so it can engage in PD-PD interactions with water. So A has the strongest interaction. Question 6. Answer is A. So what we are going to do, okay, we are going to form two half equations first, combine it to get the overall equation, and then work from there. So for the reduction, it is Fe3 plus being reduced to Fe2 plus, so it gains one electron, so this is the half equation. Next, for the oxidation, it is Fe being oxidized to Fe2 plus, so it loses 2 electrons. So here I have 1 electron, here has 2 electrons. So this equation we're going to multiply by 2 and combine. So the overall equation, 2Fe3 plus Fe gives me 3Fe2 plus. So if my reaction wants to form 3 moles of Fe2 plus, I react 2 moles of Fe3 plus with 1 mole of Fe. However, if I want there to be 2 moles of Fe3 plus alongside 3 moles of Fe2 plus at the end of the reaction, it tells us that we need to start with excess of Fe3 plus so that there is some left over. So the amount of excess that we must have is 2 moles. So we add that to the 2 moles that are involved in the reaction, which means that we need to start with 4 moles of Fe3 plus and react it with 1 mole of Fe, so that my reaction mixture contains 3 moles of Fe2 plus as well as 2 moles of Fe3 plus excess. Question 7, answer is B. So you should not be a stranger to this sort of questions. So first, we always need to find the amount of electrons transferred in this reaction. So the amount of electrons transferred is twice the amount of sulfide ions that reacted, which will be 0.13 moles. Next, we find the amount of potassium iodate that is reacted, which is the mass divided by the molar mass, will be 0.02598 mole. So we'll find the ratio of potassium iodate to amount of electrons, and you will get 1:5. So 1 mole of potassium iodate will gain 5 moles of electrons. And since in potassium iodate, the oxidation state of iodine is +5, that means that at the end of the reaction, the iodine atom has lost 5 oxidation states. So the final oxidation state of iodine will be 5 plus 5 times minus -1, which is 0. So the final oxidation state of iodine will be 0. Question 8. Which gas is likely to show ideal behavior under the conditions shown? So for this question, you need to recall the assumptions behind ideal gases. So for ideality, or for a gas to approach ideal behavior, first thing, we will need a high temperature, which means that the intermolecular forces between the particles become very insignificant. Secondly, low pressure, which means that the gas particles are very far apart. The volume of gas particles become negligible compared with the volume of the container. And lastly, the gas must be non-polar, so that again the intermolecular forces become negligible. So out of these four, okay, highest temperature will be A and B, but nitrogen is less polar than hydrogen chloride because it's a non-polar molecule. So the answer here is A. Okay, question 9 answer is B. So B, this is just a recall question asking you to recall the definition of Dalton's law. Okay, question 10 answer is C. So with 1 mole of magnesium powder, if you write the equation, 1 mole of magnesium reacts with half a mole of oxygen. Okay, so which means that the original amount of oxygen reacted, you will apply the ideal gas equation. So pressure is 2 times 10 to the power 5 pascals. Volume is 0.03 meters cubed. 8.31 is the ideal gas constant. Temperature is 600 K. So originally in the container contained 1.20 moles of oxygen gas, but I have used up 0.5 moles of it. So the percentage of oxygen consumed will just be 0.5 divided by 1.20 multiplied by 100% to give you 42%. So we move on to question 11. We have diethyl zinc being added to sodium hydroxide where two reactions occur. So which compounds act as Bronsted-Lowry acids? So before we look at the options, let's recall what's a Bronsted-Lowry acid. They are substances that act as proton donors. So the answer here is C. Why? Because if you look at reaction 1, the reactants contain water. So after the reaction, the water has actually lost 2 protons to become the oxide ion, and it combines with zinc to form zinc oxide. Whereas in the second reaction, the water has lost a proton to become a hydroxide ion. Then it combines with other hydroxide ions and zinc oxide to form this complex ion. So in both cases, right, the water has actually lost protons. So therefore, in both reactions, water acts as a proton donor, thus a Bronsted-Lowry acid. Question 12, which statement is incorrect? So for this question, you just need to calculate the how do these numbers relate to Avogadro's number, which is 6.02 times 10 to the power of 23. So the answer here is C. For option A, we note that if it's 1 mole of hydroxide ions, it contains 10 moles of electrons because oxygen atom has 8 electrons, hydrogen atom has 1 atom, then it has gained 1 electron, so it has 10 moles of electrons in total. So if I have 0.2 moles of hydroxide ions, the number of moles of electrons is also divided by 5, so 2 moles of electrons, which will be 2 times 6.02 times 10 to the power of 23, which matches this number of electrons. Option B, 1 mole of sodium sulfate dissolves in water to give 3 moles of ions, so this is correct because this is 3 times Avogadro's number. And if we have 48 grams of ozone, it would be 1 mole of ozone because it is 16 times 3 for 1 mole. So 1 mole of ozone will actually contain Avogadro's number of molecules instead of this number. Whereas for option D, if we have 1 mole of hydrogen molecules, it contains 2 moles of atoms, whereas 12.0 grams of carbon-12 will only contain 1 mole of carbon atoms. So it's twice, so the number of hydrogen atoms is twice that of the number of carbon atoms. Question 13 answer is B. So to work this out, we are going to define the enthalpy change of formation of PCl5 to be Y and the enthalpy change of PCl3 to be X. So you can use the shortcut where enthalpy change of reaction is the enthalpy change, the sum of enthalpy change of products minus the sum of enthalpy change minus reactants. So in this case, your products has only PCl5, so that this side, the sum of enthalpy change of formation will just be Y. On the reactant side, you have PCl3 and Cl2, but the enthalpy change of elements is 0. So we only consider enthalpy change of formation of PCl3. So this enthalpy change of reaction, negative 124, will be Y minus X. So negative 124 equals to Y minus X. So Y equals to negative 124 plus X. And since X is negative, question has stated that both enthalpy changes are negative. So since X is negative, it tells us that Y is more negative than negative 124. Thus, the enthalpy change of reaction is less negative than the enthalpy change of formation of PCl5. And one more thing to remember for this sort of questions is that for any element, the enthalpy change of formation is always 0. So the answer here is B. Question 14. So answer here is C. So the forward reaction has positive enthalpy change, which means it's endothermic. So our backward reaction is exothermic. So option A is wrong. And option B is wrong because the backward reaction is exothermic. The temperature of the surroundings will actually increase when the backward reaction occurs. Whereas for D, the catalyst actually provides an alternative pathway with lower activation energy. It does not affect the enthalpy change of reaction in any way. So the answer here is C. Yeah. Question 15. So answer here is D. We will need to do a bit of calculations first. So first thing, the heat involved in each reaction, we know that it is mc delta theta, which is the mass of the solutions in total, multiplied by the heat capacity of water, multiplied by the temperature change. But for each of these reaction mixtures, the total volume is always 50 cm cube. And since the density of water is 1 gram per cm cube, so therefore all of these solutions actually will have the same mass. And we also know that the heat evolved is the enthalpy change of neutralization multiplied by the amount of water. Because enthalpy change of neutralization is defined as the heat evolved per mole of water that is formed in an acid-base neutralization reaction. Right? So, we've already mentioned that all the experiments have the same volume and C is a constant. So it tells us that the change in temperature is actually directly proportional to the enthalpy change of neutralization multiplied by the amount of water formed. So this tells us two things. Firstly, the more water I formed in the reaction, the higher my temperature change. Secondly, the more exothermic my enthalpy change of neutralization, the higher my temperature change. Okay, so let's look at the statements now. For the first one, we need to write the equations, and we note the amount of alkali used and the amount of each acid used based on the concentrations and volumes given in the question. Since both sulfuric acid and hydrochloric acid are strong, they both have the same value of enthalpy change of neutralization, but you're going to notice that when we react sulfuric acid with sodium hydroxide, it produces twice the amount of water compared to when hydrochloric acid reacts with sodium hydroxide. So since twice the amount of water is formed, that means that my temperature change is also double for sulfuric acid compared to hydrochloric acid. For statement 2, this is correct because ethanoic acid is a weak acid. So the enthalpy change of neutralization for when sodium hydroxide reacts with ethanoic acid is going to be less exothermic than when hydrochloric acid reacts with sodium hydroxide. So hydrochloric acid will give a larger value of temperature change. So in the ascending order of temperature change, ethanoic acid gives the smallest temperature change, followed by HCl, followed by sulfuric acid. So which means that the greatest temperature rise does occur when using sulfuric acid. The answer is D. Question 16. Travelers to countries with cold climate use heat packs to keep warm. So this part already tells you that it is a reaction that releases heat. So delta H is negative because it's an exothermic reaction. Next, we note that sodium ethanoate actually undergoes crystallization. So what it means is that at first that there are aqueous ions, aqueous sodium ions and aqueous ethanoic ions. Then when this process occurs, they convert to the solid state, which actually reduces the disorderliness in the system. So my entropy change or my delta S is actually negative. So the answer is D. Question 17. The reaction between P and Q produces a gas. We have given you the order of reaction with respect to P and Q. And at a certain concentration of P and Q, I got 100 cm3 of gas in the first minute. So the answer here is B. So we note that the average rate of reaction is actually proportional to the volume of gas formed. So initially, when I have a certain concentration of P and Q, it forms 100 cm3 of gas per minute. So first, we are going to double the concentration of P. So because it's first order, when I double the concentration of P, my rate is going to double as well. So my volume of gas will become 200 cm3 in 1 minute. Okay, but now I will halve the concentration of Q, and because it's second order with respect to Q, when I halve the concentration of Q, the rate is going to be multiplied by 1/4, which is half to the power of 2. So my rate is quartered. So the volume of gas goes from 200 into 50 cm3 per minute. So the answer is B. Question 18. There is an equation given here, and the rate is KNO2 to the power of 2. So the order of reaction with respect to NO2 is 2. Answer here is C. So when we say that the rate is KNO2, for a multi-step reaction, the rate equation is dependent on the slow step, or what we call the rate determining step. So if the rate equation looks like this, it tells me that, or it tells you that, in the slow step, there are actually two molecules of NO2 colliding with each other. That means CO is actually not involved in the rate determining step. So there are actually two equations, B and C, where the slow step actually contains two NO2 molecules colliding with each other. But the answer is C, because you notice that for B, it produces 2 molecules of NO as a product. But my equation here only produces 1 molecule of NO as a product. So B is also wrong. The answer here is C. Question 19 shows the Maxwell-Boltzmann distribution for the gas at 50 degrees Celsius, and I reduce the temperature of the gas by 10 degrees Celsius. Answer here is B. When I reduce the temperature of the gas, we will actually skew the Maxwell-Boltzmann distribution to the left. So if looking at what I have drawn, the value of x actually increases, whereas values for both y and z decrease. So what this represents is that the average kinetic energies of the gas particles has decreased when I decrease the temperature of the gas. Lastly, in which reversible reaction would POE shift to the right when I increase temperature and decrease pressure? So the answer here is D. So for my position of equilibrium to shift right when I increase temperature, the forward reaction must be endothermic, because when I increase temperature, it would actually favor a reaction that absorbs heat, which means an endothermic reaction. So we're looking for endothermic reactions for the forward reaction. Secondly, for POE to shift right when I decrease pressure, it means that there must be more gaseous particles in the products than the reactants. This is because decreasing pressure favors a reaction that produces more gas particles. So what are the criteria for my reaction is that it is reversible, the forward reaction must be endothermic, and the reactants have less gaseous particles than the products, or the products have more gaseous particles than the reactants. So the only one that fits is D. Forward reaction is endothermic, and the products have 2 moles of gas, reactants only have 1 mole. For question 11, we have a reversible reaction between sulfur dioxide and oxygen to produce sulfur trioxide, with Kc having a value of 280. So in an equilibrium mixture at 1000 kelvins, concentration of SO3 is 6 moles per dm cube. Answer here is D. So why is it D? We need to write out the Kc expression first. So the numerator is concentration of SO3 squared. Denominator is concentration of SO2 squared multiplied by concentration of O2. And then we substitute in the numbers that we already know. So we let the oxygen concentration be X and the sulfur dioxide concentration be 2X. Then we sub in Kc is 280. Concentration of SO3 squared is 6 squared, which is 36. In the bottom, concentration of SO2 squared will become 2x squared, and concentration of O2 will just be X. So if you expand and simplify, you will get 280 equals to 36 over 4x cubed. 4x cubed equals 36 over 280. And if you solve for x will be 0.318. So 2x will be 0.636, which is the equilibrium concentration of SO2. Question 22 answer is A. Option B is wrong because a concentrated solution of a strong monoprotic base actually has a higher pH than a dilute solution of weak monoprotic base. So it has a lower pOH, that because there's a higher concentration of hydroxide ions, which means that your pH is actually higher. Option C, so when we have acids with 2 H atoms per molecule compared to 1 H atom per molecule, it's known as the basicity or the proticity of the acid, but this has no correlation to the strength of an acid. The strength of an acid refers to the extent to which it's dissociated in aqueous solution, so the proticity of the acid has no correlation to the strength of the acid. Option D, there is no distinction between strong acid and strong base. As long as you see the word strong, we assume that it means that the acid or the base is fully dissociated in water. Question 23. Which combination of solution it forms a buffer solution? So we can form a buffer solution in two ways. So either we have a weak acid and its conjugate base, or a weak base and its conjugate acid. So we need to look at these three combinations to see does it fit any of the criteria. So for the first one, when I mix these two, there will be a reaction and eventually I'm left with 0.1 mole of ammonia, 0.1 mole of ammonium ion, which is a weak base and its conjugate acid. So statement 1 describes a buffer solution. Statement 2 is a weak base, ammonia, and its conjugate acid. So it is also a buffer solution. Option 3, when I mix this, there will be a reaction to form 1 mole of sodium ethanoate, and there is 0.1 mole of sodium ethanoate and 0.1 mole of ethanoic acid excess. So this is weak acid and its conjugate base, so which means that 3 can also act as a buffer solution. 24. So which describes the types of reactions in 1 and 2? The answer here is B. So step 1 is condensation, because this carboxylic acid and this alcohol reacts together to form a larger molecule with the loss of a small molecule, which is water in this case. So that's why we describe it as a condensation reaction. After that, from this molecule, we lose again water molecules and we form a pi bond. So it tells us that this is an elimination reaction. Question 25. What statement about the derivative of jasmolone is correct? Answer here is A. It rotates polarized light as it contains a chiral carbon, which is indicated here. So this carbon has 4 different groups attached to it, which makes it chiral. So this derivative is actually optically active. Option B is wrong. It does not have 8 stereoisomers. The only stereocenter in this molecule is the chiral carbon. So it only has 2 optical isomers. This carbon-carbon double bond in the ring does not exhibit cis trans due to ring strain. And this CCC also does not do cis trans. So the only stereocenter is here, 2 stereoisomers which are optical isomers. C, it contains 6 sp2 hybrid carbon atoms. This is wrong. There are only 5 sp2 carbons which are circled in red. So 2 in the alkene in the ring. The ketone carbon is also sp2, and this is sp2. This is also sp2. You look at the number of bond pairs around it. If it's 3 bond pairs, then it will be sp2. Option D is also wrong. There is one sp3 carbon atom here. So the presence of the sp3 carbon atom actually causes not all the atoms to lie on the same plane. There will be some hydrogen atoms that are above and below the plane. So therefore, because of the presence of this sp3 carbon atom, this molecule is not completely planar. Okay, 26. A question about the mechanism of free radical substitution. So I've attached the mechanism here. Statement 1, homolytic fission occurs in both initiation and propagation. This is correct because in initiation, when the halogen molecule is exposed to UV light, the bond between the halogen atoms undergoes homolytic fission. The molecule breaks down to give 2 halogen radicals or halogen atoms. Next, for each propagation step, there will be one covalent bond that undergoes homolytic fission to form one radical and one neutral molecule. And secondly, both the first step and second step actually lead to, the second propagation step, along with the initiation, both will lead to the formation of halogen radicals. Lastly, there is a C halogen bond formed in the second propagation step, and when in a termination step, when an alkyl radical collides with a halogen radical, it also forms a covalent bond between carbon and the halogen. So option D is correct. All three statements are valid. Question 27. The answer here is C. Now, many students will think that this molecule can be formed by colliding these two radicals. But when these two radicals collide, it actually leads to the formation of molecule B. It is not possible for you to get this sort of quaternary substitution pattern from a simple free radical substitution reaction alone. Okay, question 28. X is a non-cyclic hydrocarbon, C5H10. Answer here is B. This gives you a very big hint as to what is the identity of X, because C5H10 or CnH2n can represent cycloalkanes, can also represent alkenes. But if we specify that it's non-cyclic, that means it limits it to only alkenes. So first statement, if you write the equation, you're going to find that 2 moles of X combust in excess oxygen to give you 10 moles of carbon dioxide, which is 227 dm cube of gas at STP. The water is not considered because water, as we know, at STP is actually not a gas. So statement 1 is correct. Statement 2, there are actually 5 structural isomers that is C5H10, but out of these 5, there's one of them that can do cis-trans isomerism. If you go and draw out, you can see that one of them exhibits cis-trans isomerism. So the number of isomers is actually 6, 5 structural, and one of them having cis and trans. So statement 2 is wrong. Statement 3 is correct. Aqueous bromine is actually what we call a distinguishing test for unsaturation, more specifically carbon-carbon double bonds and triple bonds. So because X is an alkene, so it decolorizes aqueous bromine. Question 29. Which compound on complete oxidation with hot acidified KMNO4 gives 2 organic compounds? So answer here is A. When this alkene A is reacted with hot acidified KMNO4, this part with 2 alkyl groups attached to the carbon in the CC, 2 alkyl groups means that it becomes a ketone, specifically propanone. The CH2 is lost as carbon dioxide. It's not an organic compound. Whereas this middle part here, it becomes a dicarboxylic acid. So there's 2 organic compounds here. Whereas the rest will only form carbon dioxide and 1 other organic compound. For C, it forms, both sides are identical, so it only forms 1 type of organic molecule, and for D, it forms again a carboxylic acid and carbon dioxide gas. Last question, we have hydroboration. So this is actually a pattern recognition question. We want to start with 3-methyl-pentoene. The structure is here. We treat it with borane, and then we oxidize it to form alcohol, right? So first thing, we need to decide how does the borane add to the alkene. And over here, we notice that when borane adds to ethene, when borane adds to this alkene, the BH2 group actually goes onto the less substituted carbon. So we are going to do the same. And we put the BH2 onto the less substituted carbon. After that, we oxidize this BH2 compound. It becomes an alcohol with this structure, which means that the answer here is B. CH3CHOH, CHCH3, CH2CH3. Answer is B.